So today we'll start sorting, and we'll actually look at comparison based sorting. So basically the sorting algorithms, the first two sorting algorithms that we are going to look at are the merge sort and the quick sort algorithms. Both are of the divide and conquer paradigm. That is, they are recursive, and they will divide the array and try to conquer each part subarrays and do the sorting in the subarrays. So basically we'll first start with the merge sort algorithm. So I guess you already know the binary search algorithm, which is also of a divide and conquer paradigm algorithm. So it's uses the same basic idea of dividing the array into two equal parts, the merge sort. So basically, let's write down the algorithm. So merge sort of an array ARR, and let the starting index be L, the ending index be R. Okay, so we are doing a merge sort. This is our function that we'll call and do the merge sort. And so define a function like this. So if L is less than R, then we'll do this. So if L is less than R, then find some M. Okay, so M will be equal to the middle element. So L plus R minus L by 2. Okay, this is M. Okay, M will be this, and we'll just call merge sort recursively on this part of on the first part of the array, that is before M. Okay, so L comma M, and merge sort, okay, ARR M plus 1 comma R. So, and then we'll call the merge function, which merges the subarrays. Okay, and we are done. So basically this is a recursive call. The merge sort, it calls itself, and we'll get a sorted sorted subarray which is from L to M, and another sorted subarray which is from M plus 1 to R, and we need to just merge those two arrays. Okay, so basically in the array we have from the middle, this part will be sorted by this call, this part will be sorted by this call, and finally this merge function is going to merge them. So basically my merge sort function looks like this. So the most important part of the merge sort is the merge function. So what it does is that it merges two sorted subarrays which are of more or less equal size, or at max one is one greater than the other. Okay, so basically what we need to do is look into how we'll merge two sorted arrays, subarrays. So basically, suppose if we have two sorted arrays, how do we merge them? Suppose we have an array A and an array B. Okay, and we need to make the sorted array C such that C is the sorted and is A plus B. Okay, so how do we do that? So we give a pointer to the last element of both the arrays, okay, and check. Okay, let's say we are sorting them from less in increasing order. So we give a pointer to the first element of both the arrays, okay, and another pointer k, okay, to the first element of C. Now we'll compare A of I and B of J. Now whichever is less, will go copy it to C of K, okay. C of K will be the minimum of this, minimum of A of I and B of J, and if its minimum is A of I, we'll do I plus plus, and my I will point at here and will do a K plus plus. If minimum is B of J, we'll, instead of I plus plus, we'll do a J plus plus, okay. Instead of I plus plus, we'll do a J plus plus, and we'll copy B of J to C of K, and we'll do a K plus plus. So basically, if we continue like this, we'll have one of the arrays will finish first, and we'll copy the remaining of the other array next, okay. So that's it. So one of the arrays might finish first, entering into this array C, and then we'll copy the remaining of that other array and append it to the end of C. So that's my simple merging algorithm. So whichever element goes into C will do that array's pointer plus plus, and that we are done. So that's the algorithm of merging. So let's write it down. So as we wrote, merge array, okay, L, M and R, okay. So basically we'll define two arrays, the left array L, which, and a right array R, okay. So, and two variables which will indicate the lengths of these arrays. So length of this array is, say, given by already used L, so let's say it's given by okay, say N, okay, say given by X, okay, and right array is given by Y. So X equal to, basically we saw that in our call of merge sort, it's L to M, and this is M plus 1 to R, the index S. So basically total number of elements from index L to index M is M minus L plus 1, and this is R minus M minus 1 plus 1. So basically the size of this array is L minus M plus 1, and this array is R minus M plus 1 plus 1. So basically this is R minus M, and this is L minus M plus 1. These are the sizes of these arrays, okay. So basically we'll copy the first half, that is from index L, ARR L to ARR M to L of 0 to L of X minus 1, okay. That's it. So basically we copy them to this, and similarly ARR M plus 1 to ARR R we copy to R of 0 to R of Y minus 1, okay. So we copy them index by index. And now we have a left array and a right array, and we take I equal to 0 and j equals to 0 as our pointers, I for L and j for R. Okay, after copying, merge algorithm goes like this. Now we have I, j, so start copying while if L of I is less than R of j, then we do C of k plus plus equal to ARR of k equals to 0 also, so ARR k plus plus equals to L of I and I plus plus. Okay, else ARR k plus plus equals to R of j, and we do a j plus plus. Either case k is getting plus plus. Okay, so basically start copying. So this continues, and we put that it under while I is less than x and j is less than y. Okay, continue doing this. Okay, now remaining part of the arrays should also be copied to C. So while I is less than x, just copy C of k plus plus equal to L of I plus plus, while I plus plus, okay, anything, while j of less than y. Okay, if it remains, if any of these remains, we just do this. Okay, j and j plus plus. So the remaining part of the array gets copied, and here we end our merge. So what we do is in merge, first copy the left part in L, right part in R. Their sizes are determined x and y. L by minus m plus 1, R minus m, I equal to 0, j equal to 0, k equal to 0. Run a while loop while I less than x and j less than y. If L of I less than R of j, okay, if the left array's ith pointer element is less than R jth pointer element, then this is smaller, then we'll copy it to ARR of k is equal to 0 initially, and else we'll copy R of jth element and do I plus plus or j plus plus accordingly. Okay, and we'll end our while loop here till one of the array gets over. When one of the array is over, we'll see that the remaining part of the other array gets copied. If suppose the first array get overs, then we don't enter into this while loop because I is not less than x, and if otherwise vice versa. Okay, the other one executes and copies the remaining part of the other array into C. In our case is ARR, and we actually have the merged array in ARR itself. Okay, so but we exactly use order n extra space because the size of L and R is x plus y, which is actually in the size of ARR and that's order n extra space we use for the merging step. So basically the merge sort that we saw here, okay, is the n by 2 if m is n by 2. So basically we split the array into n by 2 parts and do a order n merge step. The merging is basically running through the elements once and comparing them. So basically this I is moving, so basically this I and j in this total are moving order n times. So basically the merge step takes order n time, and so we see the time complexity of the merge sort as the t of n by 2 plus t of n by 2 plus order n for the merging step. This is for the first recursive call and this is for the second recursive call, and this is my recursive relation, and which we from the master's theorem knows that Tn turns out to be order of n log n. So basically the merge sort algorithms runs in order n log n time, and it is also a worst case n log n time algorithm, but the only disadvantage it has is that it uses extra order n space. So next we'll study the quicksort algorithm, which does not use an extra order n space and is in place sort algorithm, but it's not all worst case n log n time algorithm.